Okay, accelerated frame of reference question. Car accelerates from 0 to 50 kilometers an hour in 4 seconds. What angle do the fuzzy dice make with the vertical during the acceleration? So the idea here is, here you are in your car and you're driving. This is not the greatest diagram I've ever made here, and for some reason you have a rear view mirror, and hanging from the rear view mirror is a novelty pair of fuzzy dice. Like that. And as your car accelerates, let's say you're going this way, then because this pair of dice has to keep up with the car, it's going to move backwards a little bit where it tried to stay at rest, and it's going to hang at some sort of angle. So what we're interested in is, what is this angle that it's hanging at? Now we can do this from the accelerated frame of reference, from the car's frame of reference, or we can do it from the road's frame of reference, which is not accelerating. We'll do the car first, since that's the point of what we're doing here. So from the car's perspective, no, there is no acceleration, right? The car, everybody within the car should be maintaining the same thing, but we have this fictitious force, the centrifugal force, which is equal to the mass times the acceleration of the car. So here we're going to have to find the acceleration of the car, 0 to 50 in 4 seconds. So V1 is 0, V2 is 50 kilometers per hour, which is 13.9 meters per second. T equals 4 seconds. So A equals V2 minus V1 over T. 13.9 is 3.475 meters per second squared. So my centrifugal force is mass times 3.475. Now if I look at the fuzzy dice, I have three forces acting. I got a force of gravity, I got a force of the centrifugal, the fictitious force caused by my accelerating frame of reference, and then I've got a tensile force which goes off on an angle, but that's confusing. So I'm going to break it into its components: the force of tension that's in the vertical direction and the force of tension that's in the x direction. Now the force of tension in the vertical direction is going to be equal to the force of gravity, so that's going to be equal to mg, or 9.8 m. And the force of tension in the x direction is canceling the force of the centrifugal force, which I said was 3.475 m. So this must be 3.475 m. And so now I can use my two components of my tensile force to figure out what that angle must be. So if I want that angle, well, I'm going to draw it the other way because then I'll get the angle where I want it. Fty, which was 9.8 m, and Ftx, which was canceling the centrifugal or the fictitious force, 3.475 m. And I can find theta. Tan theta equals 3.475 m divided by 9.8 m, and theta works out to be 19.5 degrees. So it would swing back at 19.5 degrees. We can do this exact same problem, but from the road's perspective, or as if we're not in an accelerated frame of reference. Here, what we would think is, what acceleration do those dice need to keep up with the car? Again, we're going from 0 to 50 kilometers per hour in a time of 4 seconds. 15 kilometers an hour is 13.9. And we'd use the same formula we used, and we'd get the same acceleration, 3.475 meters per second squared. So then if we thought about our dice, we'd have a force of gravity, we'd have the vertical component of the force of tension, and the horizontal component of the force of tension, these two would cancel each other out. And this one would lead to my net force. When I get back here to the point where my force of tension X, which is my net force in this way of thinking about the problem, is 3.475 M, and then I can take that and go back to the same triangle and come up to the same angle. So if I try to treat the car, or if I try to do the problem from inside the car and I ignore that it's accelerating, I have to make up this fictitious force. Or if I don't want to go down that road, if I just want to say, if the car accelerates, then the dice have to accelerate along with the car, so I'm not ignoring the car's acceleration. This is like looking at it from the road. Then there must be some horizontal components to the force of tension causing that acceleration. That's my net force. Either way, I can get back to the relationship between how big that force is and how big the force of gravity is. And then in the end, the result is the angle that would be formed between the dice and the vertical.